This video, I'll show you how to do the kitchen table exercise in class 4 of the intermediate class at the Shipyard Night School AutoCAD program. Here's page 4-3 of class number 4. You might want to screen capture this in the next page to have paper copies along with the tutorial. The second page of the table exercise is page 4-3. Let me turn on that. And this is how it'll end up in a 2D wireframe visual style. Again, you might screen capture that and print it out. I'll leave the PDF open on the right. Let's start a brand new start from scratch drawing. Page 4-3 says draw lines and circles shown. This will be the toe of the table leg, and this will be this end here. This 3 inches at the end will be square. That'll eventually hold the 1x3 boards at the top of the leg, to which the tabletop can be fastened. Now, circles aren't well dimensioned, so just whatever looks nice to you is fine with me. Let's see. So let's start the bottom of the leg. We'll start it in the upper left corner, come down 1 1/4, draw a guideline 35 units over to the top of the leg, and come up to the 9, and then close back again, and then erase the 20 or 35 unit guideline across the bottom of this graphic. Of course, leg is shown sideways here to fit the paper better. So we'll start a line command, come down, start in the upper left corner, kind of like we did the ceiling fan blade. I'll draw a line 1.25 down. I'm just using layer 0 for everything now. 35 to the right. And let's stop the line command. I'll zoom out so we see the whole line. Okay, again, this is 35 unit line is temporary. I'll erase it in a minute. Start the line command again, endpoint O snap, come on up 2 units. Come over 9. Can't close now because I interrupted the line command. So I'll come over here and O snap with the endpoint O snap. Okay, let's get rid of this guideline before I forget about it. Now we want 3 inches left intact. I'll draw a radius of 3 circle to remind me not to interfere with that surface there. Zoom in. I'll draw some random circles, and I'll copy them and make sure I'm getting the right copy distance. I'll copy this one, O snapping at the diameters. Nope, there, O snapping at the 2 quadrants. They're spaced right. I'll draw a guideline so I can find, well, wait a minute. Center of it is the center of the center circle. I want to center these in this section, this 6-inch section here, between the bend in the table leg and the quadrant or intersection here. So I'll use the move command, select the 3 random size circles, hit enter, grab it by the center there, and I place it right in the middle here. And don't spend a lot of time getting fancy with this. I'm going to use the snap to center O snap, or snap between 2 points O snap for the second point of the move process. I shift right clicked to get the O snap overrides up. I'm going to use this one at the top above the regular list of O snaps. Midway between 2 points is where I want to move that set of 3 circles. Now it asks me, okay, which points do you want to go midway between? Well, I want to go between this end point of the 9-inch flat line and this intersection, partitioning off the 3-inch line. And there we put it in the middle. Now it's up to you how high you raise the 3 circles. Maybe, does that look good? So there'll be a couple of flat spots. Let's call that good. Maybe you should make a 4th one, but whatever looks good. Okay, let's erase and trim away. I'll wait till finish trimming to erase this 3-inch circle here, 3-inch radius circle. Launch the trim icon. We're on the 3D Modeling Workspace ribbon. I've got dynamic input, polar tracking on and set for 90, and I got the O-snap set for the usual 5. Nothing else on, all status bar buttons visible. Let's launch the trim icon. My 2022 has the trim extend mode variable set, so I don't have to select cutting edges even by hitting enter to select all cutting edges. So I'll launch I could go ahead and click away like this. Being incredibly lazy, I'm going to type F for fence and shoot it right across there. I'll click these 3. Now I can erase stuff left over. Hit enter to finish trim. I'll go to erase, and I'll cross-winding select all that stuff. So there is half of our table leg. Let's mirror it about the end points of these 2 vertical lines. Or select one and polar track either way to make a mirror line. Then join all the geometry of the leg together. So we got a kind of a cross section of the table leg, sorta. Go to modify, select join. Nope, not yet. We want a mirror. Drop down, select mirror. 2D mirror will work fine. We're in 2D anyway, looking at a top view or plan view. I'll hit enter to finish selecting. I'll O-snap at that endpoint, and I'll polar track right or left. Click no, I do not want to erase the original. Now we still got separate lines and arcs here, so let's join it all together so it's an extrudable closed polyline. Go to the join icon. Drop down section of the modify panel of the home tab of the 3D Modeling Workspace ribbon. And we'll window everything and hit enter. Let's check it out on the properties. We'll select it. Yes, we converted it into a polyline, and yes, it is closed. So this is extrudable. Okay, we finished step 2. We trimmed and joined everything. Whoops. Coming down further, we mirrored, we joined. Okay, we need to extrude the closed polyline 5 inches. Could be 10, but I'd say 5 is minimal, reasonable, but minimal. So we'll click on extrude. Actually, press pull will work, wouldn't it? Let's use press pull. I'll click here, and I'll move my cursor away and hit 5, enter. Doesn't look any different, and I've lost my, let me hit escape or enter. My navigational toolbar is lost. So I'll type the command 3DFO for 3D free orbit. And let's get the view to look like the bottom of the page. That look like the bottom of the PDF page here. Okay, I'll hit escape or enter to bail out. Let me type ID. Probably not necessary, but I want to make sure these are on, yep, these 4 are on the XY plane. So we've modeled it on the top of our imaginary table, if you will. Let's go to page 3-4. We'll copy this extruded shape and 3D rotate the copy. So we got 2 side by side here. Clicking back into AutoCAD, we'll copy it, slide it over. We'll 3D rotate it with the little atom looking icon. Select the copy, hit enter. For pivot point, I'll pick anywhere. I want to rotate it about the red handle or wedding ring. I want to rotate it 90. I don't know, doesn't matter plus or minus 90, so I'll just type 90. Now we want to overlap the 2 blocks of wood, so to speak, so they're perfectly overlapped, and we'll salvage out of this assembly of 2 wooden legs only the wood that is in both 3D models. So it kind of comes out sort of pyramidal-ish. Let's move, select the copy. I'll move it to the midpoint. Now, I'm not sure that they're fully overlapping. I'll let me manually slide it over so it's centered well. I won't take time to precisely center it. We'll slide it over. That looks good. Let's change the visual style to see that everything is in order. Yep, looks like it's well overlapped. My navigation toolbar hasn't come up. Oh, there, the recent commands came up. 3D free orbit. Let's rotate it around. Yep, looks like they're completely overlapping. Detail of each one is going to come out in the intersection. Okay, click enter. This is the original polyline from which I extruded. Interesting that the polyline survives the extrusion. Might clutter up your drawing. But now let's launch the INTERSECT icon to salvage the volume but shared by both 3D models. So it's kind of like a 2-part epoxy. Each part is on a different piece of wood. So where the 2 parts combine is going to solidify. And everything outside where the 2 parts combine can be washed away with some solvent or liquid. The intersect command is, let me move the command area where usual. Intersect command is this 3rd of the Boolean operations here. Remember, we've used union and subtract in earlier exercises. Intersect salvages just what is shared between the 2 solid models. Like the graphic in the tooltip shows, this is a pretty easy way with vanilla AutoCAD to make sheet metal parts. Other CAD systems, I'm sure, easier and better for making sheet metal parts, though, than vanilla AutoCAD. Interesting. I'm kind of lopsided on the UCS or the view. That's okay. We'll launch the intersect icon. We'll select both 3D solid models. We'll hit enter. There's another closed polyline left over from an extrusion. there's our leg. I can't think of a use for the original closed polylines from which we extruded the two views of the wooden leg. So let me go ahead and erase them both. Ah, there's my navigation toolbar back again. I still don't know why it comes and goes. Let's get back to a reasonable southwest isometric here. Actually, we need to upright the leg so it's on the XY plane. It escaped to get out of 3D free orbit. We'll use 3D rotate. I'll select the wooden leg. I'll pick a point. I want to swing it 90 degrees about the blue axis. Hoping typing 90 will swing it upward. Still not used to this newer way. I like the old right-hand rule way, rotate 3D instead of the new 3D rotate. But let's click the blue one and type 90 and see if it goes the right direction. So specify the angle, type 90, enter. I believe it did correctly. However, we're not sure if the bottom of the table leg is on the XY plane. Let's find out with the ID command. ID enter, because ID is nowhere on the 3D modeling workspace. It's kind of, I forget, down the, it's on the drafting and annotation workspace. I forget which panel it's in. Where are we? ID, specify point, we'll click, and here we're 1.5 inches high. Well, let's select it, hit enter, pick one of these points, and pick a point at random without the benefit of a polar tracking line. So I'll pick, say, here. And I believe we are now on the XY plane. Yes, Z equals 0 because we picked a random space off of polar tracking, so it defaulted to the XY plane. So why is the UCS up there? Oh, something went wrong. Okay, not sure why, but let's rotate it. So we got, let's see, XY. There. Didn't we rotate this up? Maybe I should start over. Let's do the rotate 3D again. Move it to here, pick the red, pick 90. Move it so it's in the positive quadrant. It's ID check. Yep, it's on 0. Yep, there. We got the table leg on the XY plane pointing upward. This is roughly a southeast isometric view. Theirs would be a southwest-ish. Let's leave it at southwest. Again, all 4 points are on Z equals 0, XY plane, and in the positive X, positive Y quadrant. All right, this last step is kind of vague. It's up to you. It simply says, once you got one table leg, replicate it and add some boards and a tabletop. Well, replicating it would be making copies of it. Decide your own dimensions. You know, I'll just pick random lengths. And, might be smarter to, what the heck, I'll specify a number of inches to simplify the assembly manual. if it ever goes to that stage. Let's click copy. Select one leg, hit enter, pick a random point, and carefully polar track in the Y direction. And how big should we make the tabletop? 2 by 4 feet? Is that too big? All right, the legs would be less than 2 by 4 feet. Let's say 18 inches. Double check, did I keep polar tracking on? Nope, I think it drifted away. Got careless. Let's erase. Let's try that again. Copy, select, enter. Keep on polar track and type 1-8, enter. Okay, let's double check I succeeded. That looks good. Now, the tabletop we want to be 48 inches. So let's place a copy of these two in the positive X direction. 48 minus 6 is 42 inches. And I think that'll leave the same margin. You know, the table will overlap the legs by 2 inches all the way around, if my math's right. Let's go to copy, select everything at random point, snap into the polar tracking. There we go. Polar tracking in the positive X direction. 42, I believe I said, right? 24 to 18 was, yeah, I think we want to go 6 less than 48. So that would be 42, enter. Enter to finish the copy command. Now, these square spots are 3 inches tall. Let's make some boxes on the XY plane and position them up, and then we'll slice them to fit. Okay, we'll decide how to work the corners as we go. I'd rather not take time to miter them. So we'll have end grain showing somewhere. Let's have the end grain visible on the narrow sides. Okay, so the long pieces will hang over extra both directions to cover the short boards. So the end grain of the long boards will be visible standing on right or left in the current view. Let's make a box, pick a point. We want to do length. Snap into the X direction. Make it plenty long enough. Yeah, say this is, yeah, what the heck, 48, enter. What's the width? Let's say we're using 3/4 thick wood. 0.75, enter. The height, be careful to have your cursor upward. That's 3 to go on that top piece. So far, so good. Let's move it into position. Think ahead. I'll grab it by that end point and snap it to that corner. And we want it to hang off 3/4 of an inch in that direction. So let's nudge it a hair further in the negative X direction. 0.75, enter. We'll wait to place the short board and use it to slice the surplus off. Meanwhile, let's mirror this board to replicate it to the other side. We'll use that midway between 2 points to find a mirror line on the XY plane. Have a mirror line centered between the legs to reflect this straight over. Use the old 2D mirror command. I want to select this, hit enter. The first point of the midpoint, I want to get exactly midway between these 2 points. So I'll use that snap override again, hold shift, right click, pick midway, mid between 2 points. It saves us the work of drawing a guideline and snapping to its midpoint. And I'll say I want it midway between that end and that end. So there's our midpoint. Polar track positive or negative in the X. Click no, I don't want to delete. Okay. You could draw another box. Let's just copy one of these and rotate it. We'll 2D rotate it. I'll pick a midpoint and type 90. Doesn't matter which way it spins. And we'll go to move, select it, enter. I'll grab it there and snap it there. Okay. Let's slice this board so it's right at the edge of the long board here. You slice a few times, click slice, select the board, the short board or to be short board, hit enter for 3 points. And we need to pick 3 points on the 3-inch wide surface of this long board. Well, these top and bottom end points are certainly on that surface. And we could go over to the midpoint. NEA for near would be avoid having to pan out to reach the midpoint. And enter for both. And we'll erase the surplus. Clicking on the right, in the right spot would save having to erase it, but I'm in the habit. Let's mirror this new board the same way we did, or this time let's draw a guideline instead of that midway between 2 points. You decide if midway between 2 points is good. There, we'll mirror about it midway on this line from that point to that point. Go to 2D mirror. Oh, yeah, this will work. Select what we want to mirror, hit enter, snap at the midpoint of that guideline, and polar track in the positive or negative Y direction. Click no. All that's left now is slicing the 2 long boards on 3 points on the short board here. I don't believe I've tried before, but let's see if you can slice 2 pieces at the same time. They might turn into the exact same solid, though. I've seen cases where you end up with a solid model that clearly is 2 pieces with air between them. Not doesn't work in reality, but it works in 3D modeling. Let's use slice. Select both long boards, hit enter. I'll pick 3 points on this surface, mid there, and say an end there. Enter. I believe it sliced both of them. Recall hitting both, but it's okay. We'll erase this little stub and that little stub, enter. Get rid of our chalk line before we forget. Now, let's draw a rectangle that fits on the outer edge of these 3-inch wide boards. Rectangle, because we can quickly offset it out and fillet each corner. Remember, the fillet command has a polyline option. So we'll start with a rectangle. snap at that end point, and say and specify other point. Well, in an unusual case, we know where the other point is, so we'll snap there. Okay, let's offset it. Launch the offset icon. Specify the distance. Let's go, I don't know, 4 units. I forget what we originally planned, but this will be a slightly bigger than a 2x4 foot tabletop. Let's go 3. And I won't bother to do the math to figure out the final size. We'll offset it 3. Now, can I select that polyline we just picked? Not sure. If I might select the okay, cannot offset that object. All right, let's hit L, enter for the last item created. Okay, type L, hit enter. And why did it expect a point? Offset, select object to offset. Why did that not work? L, enter. Interesting. Can we move it straight up a few inches? Move, L, enter. Got one found. I'll move it straight up. The z-axis, say 4 inches. Now we got a clear shot. We can offset it and then move it back down 4 inches. Click offset. Specify the distance. We'll say 3, enter. Select the object to offset and click out of the original rectangle. Let's erase the original rectangle before it confuses us. Let's round off these corners. That can be done with the fillet icon. Click fillet, change the fillet radius to say 3. Enter. Now invoke the polyline option of the fillet command to fillet all 4 corners of this closed polyline. Click. Go back to type a command. Let's move this straight down. Would I move it 4 inches, I believe? Move, select, pick a random point, polar track downward on the z-axis and type 4, enter. So now that polyline lines up with the top of all those legs. Let's extrude the offset and filleted closed polyline upward, say 1 inch, to make it a 1 inch thick tabletop. Extrude, select the polyline or the modified rectangle, enter. Aim our cursor high and type 1, enter. There is our table. Might be easier to understand if I change the color as we made parts. But on either end view, you can see the end grain of the long pieces. You don't see any end view looking at the, directly at the long sides. So double check, see if I may have messed up. No, bottom of the legs are still at z = 0. I'm confident there's no interference. Let's take a look at 2D wireframe. That looks pretty much like the PDF. Let's call it good enough. Save your file if you want. See you in the next tutorial. Goodbye.